I'm Armstrong, and I'm going to be the announcer for this evening's event in this room. I'm currently part of the Quest Quality Guild, and I also teach the introductory course for Quest students to help prepare them for this wonderful capstone experience. Right, so this evening, we're going to start first up with Team Takeoff. Come on up, guys. Team Takeoff will be presenting their project, which was looking at the quality assurance lab at Tulkoff Foods. They were looking for ways of improving efficiency and figuring out other ways of helping reduce the impact on production. So as soon as we get the slides up, so let's give another welcome for Team Takeoff.
All right. Hello, everyone. Thank you all for coming tonight. My name is Sam, and these are my wonderful teammates. This is Hannah, Eric, Nicole, and Camille. So our client this semester was Tulkoff Food Production Incorporated. So Tulkoff is a third-generation, family-owned and operated company that specializes in the production of sauces and condiments, such as horseradish, garlic, and pesto. Just as of last year, Tulkoff produced over 41 million pounds of product. Currently, Tulkoff is headquartered in Baltimore, Maryland, with a facility in Pittsburgh, California.
So our project wanted to focus on the quality control lab. After each stage of production, they do a series of testing, and we wanted to see how we could reduce this product. We wanted to determine the bottlenecks in the product, and then hopefully decrease the throughput time. So I'm going to go over the current process. So here's Joe. Joe works in the Tulkoff production. So after, again, they produce a variety of products, and after each phase of production, they have to run a series of tests. So Joe takes a sample and brings it to the quality control lab to be tested. So in the quality control lab, it goes through a series of tests. There's about 9 different tests that it can go through, and not every product goes through the same testing. Because of that variance, there's a big variance in duration for the testing in the lab. On average, it takes 14 minutes with a standard deviation of 12 minutes. This can range anywhere from as short as 3 minutes to all the way to 60 minutes. Because of this, Joe doesn't know when his test is ready. So after a few minutes, he goes to the lab to check. It's not ready, so he goes on back. He does a few more things, waits a while, checks again. Still not ready. So the technician finishes the test and fills out an approval tag and puts it on the window. Because Joe's not in the same area as the lab, he doesn't see this. We observed, on average, a delay of 2 minutes. So eventually, Joe comes to the lab one more time, picks up the tag, and is able to move on to the next phase of production. Now, this delay and the walking back and forth account for 3 hours and 12 minutes of time wasted every single day. And this is just a minimum estimate. Most production workers are like Joe. They come back and forth and check. But occasionally, a worker will actually wait at the window for the whole 14 minutes, resulting in even more waste. So we really want to examine this process and see how we can reduce the waste and also reduce the time.
All right, so now that you know the current process, I'm going to jump into our proposed solutions. So our solutions are twofold. The first of which is to increase communication between the quality control laboratory and the production floor. The second is to reduce the throughput time within the quality control lab. So I'm specifically going to go into the increased communication. So we decided to implement an approval alert system. So currently at their batching, they have a touchscreen monitor that they use to monitor the product as it goes through the process. So what we've decided to implement is a red light, green light system that will pop up on this touchscreen pad and let the production worker, Joe, know whether his product is ready to move to the next step. So the way this works is, first, the sample completes its test within the quality control lab. So next, the approval will pop up on the touchscreen, and as you can see here, everything passed except for PESTA. And what we wanted to make sure is that they would know specifically what failed. So here, the PESTA was low in salt. And then, now that they know this, they can either move on to the next step of production, or they can adjust the batch accordingly.
So the next opportunity that we saw was adjusting the equipment that's inside of the lab. So one of the tests that we noted as a potential source of improvement was the drain weight test. So drain weight test is when you measure the free liquid in the sample. So basically you're looking at the sedimentation time. We found that this was the longest test of any that the samples go through. So we looked at our data, and we found that on average, samples that are tested with drain weight last 4 more minutes in the lab than samples that do not. So this means that the production or the packaging is halted by 4 minutes. We also looked at the test occurrences. So we found that 71% of the samples that were tested last year went through the drain weight test. So if it has a lot of time added and a lot of samples go through the testing, that means we have a potential source of improvement. So we looked at ways that we can solve this problem. And what we found is that the failure rate for the drain weight test was 0.0001%. So this means that only 1 sample failed in all of last year. So what we propose to do is we propose to adjust the approval system. So we propose that rather than waiting for the drain weight test to be completed, that we actually just start the test, approve the sample for packaging, and then document the test after packaging. This will reduce the time to 10 minutes. The next opportunity that we saw was looking at each of the individual pieces of equipment in the lab and seeing if they could be upgraded or some other way to sort of enhance the throughput time. So the first test was acidity. This is just measuring the acidity in the sample, how much acid is there basically. After that, we looked at viscosity, which is measuring the flow of the sample. So whether it flows very quickly like water or slowly like shampoo or something like that. So it's not important how they currently test these, but what's important is that each of the tests that they currently run require continuous attention and are very lengthy. What we propose to do is replace them with automatic systems. So an automatic titration system and an automatic viscometer, which will document the exact same parameters, just a lot faster. So there are a lot of different things that this improves. This improves the cleaning time and the testing time, which obviously will decrease the throughput time in the lab. But I also want to talk about the increased accuracy of these tests. So currently, a lot of tests are retested while they're in the lab, which obviously doubles the time required by that test. And they're usually tested again in the case of human error, which we eliminate with an automatic system, or just inherent deficiencies in the test. So these improved accuracy of the test will also increase the throughput time of our samples in the lab.
Here's a generous timeline of our recommendations. As you can see, our timeline is very short. We want to focus on lean solutions that were cost-effective and easy to implement. For now, we want to change the approval requirement to allow the drain weight test result to to allow production to continue before getting the drain weight test result. This change can happen tomorrow and an immediate result can be seen. In 1 to 2 months, we would like to invest in new equipment that will reduce overall test time. We do not expect much, any changeover costs, and we actually expect the new equipment to be easier to use than the old equipment. In 1 to 4 months, we would like to install the approval alert system, which will improve communication between the quality control lab and the production floor.
We also see some long-term benefits, so not the immediate ones that we've just discussed, but in long-term that the entire process within the lab will be completely paperless. So right now in the quality lab, the technician writes lab results or test results on a physical piece of paper, and then in her downtime will input them into the computer. What we're proposing is that she put them directly into the computer, and this data, once all tests are complete, will automatically populate that touchscreen that you saw in one of our examples. The second is that this will allow kind of a platform for real-time data analysis. So what we see is once all this information is automatically put into the computer, this gives Tulkoff the opportunity to do some background programming and potentially run some analysis in the background that will automatically tell them, maybe salt test is failing a lot, so you should look at that piece of equipment. Or maybe pesto is failing very often at this stage in production, so you might want to revisit the recipe or something like that. And then the last is increased communication between departments. So as you saw in one of our recommendations is more communication between lab technicians and production workers. But we believe that it could go further than this. So not only will that communication improve, but there will also be with more data in the computer, it can be shared more easily with other departments, which could have benefits such as more informed planning or something like that could take into account the amount of time that a product will spend in testing before it can go on to the next phase of production. So you may be wondering what's the actual impact of all these recommendations? And that impact is actually twofold. The first of which is a 10% overtime reduction. So with all these things that we're doing to save time, we can reduce overtime within the next year by about 10%. This equates to about $23,500 within the next year of savings. The second is 890 freed hours of labor. And this labor is shared between production workers and also the lab technician. There's not many of these workers, so it's a big deal because it's not spread over a large number of people. Each person will actually be have a significant number of free labor hours per day and throughout the year. And this equates to $14,500 of savings. So together, we can see $38,000 of savings within the next year. This means over the next 5 years, we can see $181,000 worth of savings. And what's the cost of all this? It's a small fixed cost of $8,000. All of which is incurred within the first 2 to 3 months. And as you can see, the payback time is very quick, also within a few months. And it's a very lucrative set of recommendations that we have. On that, we would like to thank our faculty advisor, Dr. Armstrong, and our project champion, Rose, and the rest of the Quest community. And we'd be happy to answer any questions you may have about this project.
Yes.
Was that 3 hours amongst all workers or just one worker in particular?
So the question was that 3.2 hours per day spread over all workers or just one worker? So that amount of time is actually spread over all production workers. And from what we've seen in our time on the production floor, I think there's about 10 to 15 people on that team.
Now you mentioned taking out the drain water testing and just going straight to approval. How does that change the quality of a product that's being produced?
So the question was, how does removal of the drain weight test affect the quality of the product? So by FDA standards, they still have to test the free liquid in the samples of the drain weight test. We just found that since it fails so little one time in a year, that we can go ahead and package it before we get the results of the test. And another thing is that oftentimes when the drain weight fails, because it is the free liquid, you're going to notice it by eye. So there's also a visual test that all the products go through, and you'll probably see that it's going to fail the free liquid test because it's either going to be a block of soap or a slushy, ice from 7-Eleven. So depending on what it looks like, you could also already say that it's going to fail, and then the proper measures can be taken then. Sure.
Just wondering, based upon the what this company does a year in terms of gross revenues, what kind of percentage you're talking about in terms of the savings that you're proposing?
So the question was, based on the entire revenue of the company, what do these savings actually look like on a bigger picture? So we actually weren't able to aggregate all this data. It was a little bit difficult to collect some of the financial information, but we believe that by reducing overtime by 10%, I mean, that's a huge percentage, and I believe, well, the overtime rate is not quite double, but it's almost double the amount that a production worker gets paid during regular hours. So just on that alone, it would be a huge chunk of savings.
All right.
Oh, we can take one more.
Okay, I have two questions. So at the beginning of the process is when you do the batch testing, or at what stage of the production run you do the testing? And the second question is, while some testing is being done at the lab, do we continue with production or do we wait for those results?
So the first question was, actually, can you repeat it one more time? I'm sorry. I heard the second question.
At what stage of the production run do we do this batch testing in the lab?
So the first question was at what stage of production? And the answer is every stage. So they have to do it between every single stage. So some products get tested 3 or 4 times. And for the second question, yes, production is halted. So they cannot keep making the product because they have to wait, which is why the improvements are so crucial to reduce the overall